Alright guys, welcome to part 2 of linear programming. But it is basically lines and it is used to find the optimum solutions. So there are more than one, but you try to find the best solution. And this was invented in the war, and they would use resources like the must, alright? You have 10 bomb, 7 shotgun, you know, and they would say how many people they can kill. So it's all about sharing up resources and all of that. So it's an optimum. Alright, let's go. So let's say a boy has $280. He wants to buy X records at $35 each, Y tapes at $40 each. He must buy more than one tape, but not more than 4 tapes. He must also buy at least 3 records. Right? Inequalities in X and Y to represent the data. Now, you see how many things happening, guys? What you have to do is basically separate them, right? So it says that a tape costs $40 and a record costs $35. And then this is the limitations, right? He only has $280. So for the first inequality, we definitely look at the money part of it, right? So let us put things into perspective. So whatever, the first one is 35, so it's 35 X, right, that is the record, plus 40 Y, and that is less than or equal to 280. So you can spend less than 280, but you cannot exceed this, right? So that is the first equation. Now the next one's condition said he must buy more than one tape. So we can just begin that. So tape, Y represent tape, so that will be 1. See, this means X greater than 1. And let us see what else they say. Not more than 4. Alright, so that's the limit. So it must be E less than or equal to 4. Oh, this should be Y. Because of that represent Y, right? Alright, now it says that he must buy at least 3 records. See here? At least. At least mean 3 must be the minimum. So you can buy 3 or more. So that would be X is greater than or equal to 3. So you can buy 3, you can buy 4, because that is greater. So that would be the inequalities. Alright. B says determine the maximum amount spent and state X and Y give this amount. Now what they're asking us to do is to basically draw all of these 3 inequalities and see where the shaded region lies. So these, let us graph these and then we can. Alright, so what we can do is basically, I'm going to rub off at this, but let's go. So we have 35. That's equated, right? To 280. What we're basically doing is to solve for Y. Or we can just divide both sides by 7. Since all of them is a multiple of 5. So that is 8Y. So we simplify it. It's 5 into that. 5, 25, left 3 to that. So that's 56, right? So what we need now, we can just make Y the subject of the formula. So 8Y is equal to 56 minus 7x, and then we divide by 8. So that's the general formula. Y is equal to 56 minus 7x over 8. What we need to do now is to find out where it touches the line touches the x-axis and where it touches the y-axis. And this is the line y equals 0, and this is the line x equals 0. So all we have to do is just equate both of them. So when x is 0, let us see what is y. So x is equal to 0. That will be 56 minus 7 times 0 divided by 8, and that is the same thing as 56 divided by 8. So it's equal to 7. So for this, it means that the graph is going to cut the y-axis there. Alright, let us go for when y is 0, and that is the x-axis. So we equate it. So put back the equation. Equation is y, or y is 0, so put 0 here. So 56 minus 7x over 8. 8 times 0 is 0. We're left with 56 minus 7x. Cover this, it becomes minus 56 is equal to negative 7x. We can divide by 7 now, negative 7. And that gives us 8. So it means it's going to cut it right there. Alright. So I'm going to have to clean the board. That's just the equation, how to get. I'm just showing you how to get the lines, right? And then we're going to look. So this is for this one. That line we're drawing right now. But I need to clear the board first, and then we can proceed. So guys, I took the liberty of drawing the line. Alright, so we draw this one already. So we need to draw this region now. Now y is greater than 1 and less than or equal to 4. So we go at 1. We're going to use a different color. Y equal 1 will be this. And it goes up to 4. So basically, just draw a line. Do it real quick. What we actually drawing is a region where y is greater than. So it will go up in this. Right? Alright. So let us draw x is greater than or equal to 3. So first we find 3, and the greater than would be to the right, so it's 3 right here. Alright, and greater than would come over here, and less than for this will come right here. So the answer, or the solution that we're searching for, is basically where these 3 lines, this 3 shaded region meet, right? So we have black, blue, and red meeting up together. Alright, so now what we're basically doing is writing the points. So this, taking the intersections. So this would be 7, 1, x is 7, this is 3, 1, and this is the point 3, 4. So all we do now is plug in these numbers into the equation and see how it goes, right? And one with the highest value. So let's go. So right by the formula, 35x plus 440y. Let's see what we get. Alright, so x, let's just call this one A, this B, and this C. So point A will give us 35. X is what? 3. 40. Y is 4. I mean, I calculator for this. Calculator quickly. Alright guys, I just have to pause the video and do this quickly. So 35 times 3 is 105, plus that is 160. So we add that and we get 265. Remember, the answer was the one with the highest value. So the 105 plus that 195. No, 105, that's 145. And this would gives us 285. So therefore, the solution, the optimum with the highest value, which is this. So it's at the point 7, 1, and this is called the feasible region. Sometimes they will ask you about that. Alright guys, thanks for watching. Remember to like and subscribe, share with your friends, alright? More past people coming up.